All right, I'm going to talk to you about exterior angles of polygons now. So a couple of properties of exterior angles, and more importantly, just what are they? What is an exterior angle of a polygon? So I have a couple pictures here, and the definition of an exterior angle of a polygon, which just says that an angle is an exterior angle of a polygon if and only if it forms a linear pair with one of the angles of a polygon. So I have two triangles here on the screen. I'm going to take a look at this one here first and kind of describe exactly what an exterior angle of a polygon is. And it's going to be true of any polygon. I'm using triangles here, but the idea will remain exactly the same. So most might think, and it makes sense, that an exterior angle is on the outside of a polygon, which it is on the outside. But it's not the entirety of what you might think is on the outside of the polygon. So for instance, I have this triangle right here, XYZ, or XZY is the way that I'm going here. And now an exterior angle is on the outside of the polygon, or the triangle here, but it has to form a linear pair with one of the angles on the inside of the polygon. So if I look at this angle Z right here and say, well, here's the inside, so the exterior angle must be this whole thing around, and that makes sense because it's on the outside. This whole thing is not the exterior angle of this particular angle of the triangle. Exterior angles are formed when you essentially take one of the side lengths and keep drawing it along here. So notice I keep drawing this along, and when that happens, I form an angle right here, which would be angle 2, and that might be kind of confusing because this one's going as well, because I can go either way. Now notice here that I have one angle and a second angle here, and these angles, based on what we know about angles, they are congruent because they are vertical angles. Each one of these angles is an exterior angle. So they're only each exterior angles. They're not exterior angles together. Only one of them is an exterior angle, and it doesn't matter which one you pick because they're exactly the same. So the exterior angle to this angle right here, which would be XYZ, is this angle 1 here or this angle 2 here. It doesn't matter. And each one of those forms a linear pair with this angle on the inside. So angle 1 and angle 2 are exterior angles at angle X, Y, Z, but we only choose one of them. So it doesn't matter which one you choose because they're vertical angles. When we look over here at this triangle, we can find certain measures of exterior angles, and this kind of gets a little bit better picture of what the linear pair is as far as interior and exterior angles go. If I keep drawing this line out, this side length here, you notice this is 22 degrees. This angle right here is an exterior angle, and this angle is going to be 180 minus 22, which would be 158 degrees. And I easily could have just extended out this one right here, this side length over here, and I would have formed again another 158 degree angle. And same thing here with angle CBA. Here's 116, so the exterior angle is when I take that side length and keep drawing it out. This is the exterior angle at that angle CBA, and that's going to be 180 minus 116 because they're a linear pair, so on and so forth. And then this angle on the inside of this triangle, I can find the measure of that because these three angles here on the inside of the triangle should add up to 180. So it's going to be 116 plus 22, which would be 138. 180 minus 138 is 42. So this angle is 42. And then this angle is going to be 180 minus 42 because it's a linear pair, which would be 138. And 138 is what these two things are, so that brings us to our next idea. The exterior angle theorem for triangles says that in a triangle, the measure of an exterior angle is equal to the sum of the measures of the interior angles at the other two vertices of the triangle. Got that? That seems pretty straightforward, huh? Here's what it's saying. In this triangle, we have the interior angles, angle 4, angle 5, and angle 6. And then at each of those angles, we have their corresponding exterior angles. So here's an exterior angle, at 5. Here's an exterior angle here at 6. Here's an exterior angle at 4. So this is a nice picture of where we have a triangle or a polygon, and then we have all of the exterior angles drawn. And notice again, as I mentioned before, only one of them is there. That's all we need. That's an exterior angle. What this is saying here is that if you take angle 2 is going to be equal to whatever angle 4 is plus angle 6. And angle 3 is going to be whatever angle 5 is plus angle 4. And whatever angle 1 is going to be equal to angle 5 plus angle 6. Now this is something we could probably just figure out if we were given measures of angles. But this makes sense because on the inside of the triangle, all of these angles should add up to 180. And then each interior and corresponding exterior angle also adds up to 180. So therefore that exterior angle has to be the sum of the other angles in the triangle that are not included with the one that is corresponding on the interior. So that's what this is saying here, and here is the equations that kind of make sense of this picture. This will always be the case. Might be something that you don't necessarily need to remember, because if you're given two angles in a triangle, you could easily find the last angle because they add up to 180, and then the corresponding exterior angle because the exterior angle and an interior angle add up to 180. So there's quick 6 minutes of exterior angles and some properties about them that will be useful to remember.